Good morning, students. Topic for today is complexity of algorithm. We all know that algorithm is a step-by-step process to solve a particular problem. Algorithm is very important for program development. Each algorithm must have the five main characteristics. Number one is input. It must receive an input. Output, it must produce at least one output. Finiteness, it must finish after finite number of steps. Then comes definitiveness. The steps performed in the algorithm must be clear and unambiguous. Fifth is effectiveness. It provides solution effectively without much wastage of memory and time. Now, let us first understand what you understand by complexity of an algorithm. Complexity of an algorithm is the time and memory taken by an algorithm to solve a particular problem. Complexity of an algorithm is very important because it tells us how effective an algorithm is. The complexity of an algorithm is analyzed in two terms. First is time complexity. Time complexity is amount of time algorithm takes to arrive at a solution. It includes number of comparisons between the integers, number of times the loop is executing, number of memory accesses performed. Then comes the space complexity. Space complexity is amount of memory an algorithm takes in terms of input and output. Cases for algorithm complexity are best case. It is the minimum time taken to solve the problem. Worst case is the maximum time taken to solve the problem. Average case when time taken is between best and average case. Let us consider an example of an array to understand these cases. Consider 10 element array. The algorithm performed on this 10 element array is to search an element in it. First of all, if element to be searched is 18, then going starting from the first element and going to last element, we have to make 10 comparisons, and this is the worst case. If element is to be searched is 12, then number of comparison will be 1, and this is the best case. If element to be searched is 17, then 5 comparisons are to be performed, and this is known as the average case. This is how the complexity of an algorithm is calculated, and worst, best and average case are analyzed. Then coming on to big O notation. Big O notation is used to analyze the complexity of algorithm. Big O notation characterizes functions according to their growth rate. The O notation for a function fx is derived by the following simplification rule. If fx is the sum of several terms, the one with the largest growth rate or the highest power is kept and all others are omitted. If fx is the product of several factors, then constants are omitted. Let us understand this definition of big O notation based on some examples. Let fx is equal to 6 into x raised to power 4 plus 2 into x raised to power 3 plus 5. Then here the highest power is x raised to power 4. Therefore, we have to consider this and ignore all others. Therefore, f of x is equal to O of x raised to power 4. Let fx is equal to 7 into x raised to power 5 plus 4 into x raised to power 3 plus 5x. Here highest power is x5. Therefore, f of x is equal to O of x5. Let us consider an example where multiplication is used. Let fx is equal to 2 into x raised to power 4 into 4 into x raised to power 3 into x raised to power 2. Here powers are multiplied. Therefore, we have to omit the constants and add the powers. Therefore, f of x is equal to O of x raised to power n. 9. Then coming on to analyzing algorithms in terms of big O notation. First of all, consider simple statement sequence S1, S2 up to Sk. Then the time complexity here is O of 1 as long as k is constant. Runtime is constant and it will not change. Then coming on to second example of simple loop. Here the loop is executing n times, therefore the time complexity is O of n. Runtime is linear and it is directly proportional to n. Then consider the example of nested loop. Here we are taking two loops and each loop is executing n times. Therefore, the time complexity is n into n, which is equal to n square. So, time complexity is O of n square because the outer loop will be executed n times and the inner loop will be executed n times. Runtime will be quadratic and the running time will be proportional to n square. Let us consider the order of some common function in terms of big O notation. Notation is O of 1, which is called as constant. An example is algorithm to check whether a number is even or odd. Then O of n, linear. When we search an element in linear array, then complexity is O of n. Then O of n square is called as quadratic, and bubble sort and quicksort algorithm are having quadratic complexity. Then O of log n is called as logarithmic. An example is binary search algorithm. Then O of n log n, it is called as log linear, and examples are heap sort and merge sort algorithm. This is all about the complexity of an algorithm. Thank you.